Greetings, everyone. I'm Edouard Desplanches, your host for today's webinar on the HB1 generator circuit breaker system. In my role as the head of product and portfolio management for the GCB application at Siemens, I'm thrilled today to guide you through this session. Today's session is not just our typical webinar, it's an interactive experience. And as such, feel free to raise your question by using the question button, which is located in the app's top right corner. Now, let's extend a warm welcome for Fabian Rademacher, our product lifecycle manager for HB1. Hi, Fabian. Welcome to the session.
Hi, Edouard. Thank you very much for the warm introduction.
Pleasure to have you. Fabian, one word, the stage is yours. We see each other at the Q&A session at the end of your presentation.
Of course, we will do.
Best of luck, Fabian.
Thank you. All right. Also, very warm welcome from my side. My name is Fabian Rademacher. I'm the product lifecycle manager of the new generator circuit breaker system HB1, and it's a pleasure for me to introduce you this new system and to unveil it to our customers. So, what are we talking today, and what I want to introduce you to today? Of course, each and every webinar is starting with a small introduction what we are doing at Siemens in the Department of Generator Circuit Breaker System department. Second, of course, to understand why do we need a generator circuit breaker is very important, also to make the difference to the distribution circuit breakers. Then, on the third, I'm going to introduce you the new HB1, what makes it so special, and what is actually the benefit which can you take out of this new switchgear. And last but not least, we are going to have to say, or I will wrap it up. I will give you some key takeaways, and we are going to start the Q&A session, where I'm going to welcome back Edouard on stage. But first things first. All right. Let's start with the short and brief introduction of the Siemens generator circuit breaker business. With our generator circuit breakers, we assure that we can protect the assets of our customers in total of a global energy generation of up to 80 gigawatts. In terms of vacuum interruption technology and generator circuit breaker business, we do have more than 40 years of experience in developing a vacuum interruption technology and also in managing successful projects. Our portfolio achieves more than 75% of OPEX reduction for power plant operators. And globally, if we are wrapping up the whole generator circuit breaker department, including all the region of Siemens, we have more than 60 persons working for this specific branch and for this product. Annually, we will provide, and we can provide to our customers more than 500 technical configurations, we are providing this, and we can offer you the best solution. If you want to digitalize your switchgear, we can also provide a Ciprotec or an Asset Guard, which will be then integrated in our switchgears and will make your digitalized life much more easier. And of course, which we are very proud of, is that Siemens is actually the technology leader of having a vacuum interruption technology available up to 110 kA, which is very unique for us, and we are very proud of it. So, of course, I've told you that there might be some differences between a generator circuit breaker and distribution circuit breaker. When we are talking about generator circuit breaker and its application, we are going to start at the power generation, so the generator or the generator and turbine set. It will be then connected via an IPB or any kind of connection to the generator circuit breaker, so the equipment to protect the generator, and then further on the generator step-up transformer side via an IPB, SPB, or any other types of connection to the generator step-up transformer. And the generator circuit breaker is very crucial. So it might not be the most expensive part of the chain, but it is very, very important to protect the generator and the generator step-up transformer, because it can clear a fault and protecting the generator and generator step-up transformer of being damaged, depending on the fault location. When we are talking about generator circuit breakers and we are applying it in the medium voltage, range. We are going to improve the protection of the generator, step-up transformer, and the generator. If we are having an auxiliary branch, of course, the auxiliary branch can also be protected. We can, a generator circuit breaker typically or in total is going to increase the power plant availability by simpler operating procedures and a high degree of selectivity, which means that in terms of, for example, of a generator maintenance, we do not have to switch off the whole power plant via the high voltage circuit breaker, but we can select a generator circuit breaker in the generator branch to open and to having the maintenance on the generator but still having a live part of the auxiliary branches. And of course, a generator circuit breaker will provide you a reliable synchronization by synchronizing the generator voltage with the high voltage side, and making sure that you do not have. Of course, you can have an out of phase fault, but to be able to clear it again afterwards if it is going to happen. So then it is also important to understand about the different fault locations a generator circuit breaker can face. On the one side, we are talking about a system source fault. For a system source fault, the fault location will be between the generator and the generator circuit breaker. The system source fault will have a typical or a similar behavior as a short circuit current, which you will have in the distribution network, for example. So no delayed current zero, very high short circuit currents, and a very high rate of rise recovery voltage and transient recovery voltages. On the other side, and this what it makes so special for a generator circuit breaker, we can have the fault location between the generator step-up transformer and the generator circuit breaker. In this case, we are calling this short circuit current generator source short circuit current. And what makes it so special is that you do not have instantly current zeros, but the generator circuit breaker has to withstand the thermal stress of not having these delayed current zero and still to provide a reliable current interruption. And normal distribution circuit breakers are actually not type tested for this case. And that's why we need generator circuit breaker in power plants. So of course, as I said, we have to make a difference between distribution circuit breakers and generator circuit breaker. And that's why we're also having different standards. We do have the -100 standard from the 62271 series, which is only facing the distribution circuit breakers. And we do have for the generator circuit breakers and for the generator circuit breaker system, the 62271 37013. The very special and unique standard, which is only facing the applications of generator circuit breakers and nowadays also their systems. And this is what we are facing with at the generator breaker switchgear department. All right, coming to the Siemens portfolio about generator circuit breaker switchgears and systems. We can offer from 50 megawatts up to 450 megawatts. So coming from a very small power plant going to huge hydropower plants, for example. But today, as we are going to have the HB1 introduction to the market, I want to highlight the HB1, which can cover rated currents up to 5,500 amps, a rated braking capability of 72 kA, and a rated voltage up to 17.5 kV, and so securing a power generation of 140 megawatts. So now you might be curious how this new HB1 will look like. Of course, we are not inventing a new wheel, but we are taking the best practices from our products, bringing it to a new switchgear, which is now called HB1, or which is now the new HB1. It will withstand, or it is a type tested for a rated voltage up to 17.5 kV, in compliant with the generator circuit breaker system standards, so the 62271, 37 or 13, meaning that we do have an insulation level of 50 and 110, type tested, fully type tested. We can have a degree of protection of up to IP55, and making sure that at the degree of protection of IP55, we still have a rated current of 5,500 amps at an ambient temperature of 40 degrees Celsius. Taking the full power out of the equipment which is installed in the HB1, we are having a rated short-time withstand current of 72 kA, which can flow up to 3 seconds, and having the rated peak withstand current also in compliance with the generator circuit breaker system standard, which is 197 kA peak. And of course, if it is needed, there might be some cases where an internal arc classification might be required. We made sure that we are testing the new HB1 according to the -200 standard, because in the generator circuit breaker system standard, the internal arc classification is not mentioned, but based on the ratings of the IEC IEEE standard. So we are having 63 kA for half a second with the generator circuit breaker system standard peak of 173 kA, fully type tested and fully confirmed by an independent test laboratory. So what's actually inside the HB1? Of course, if we are coming from the generator, from the top of the generator, we are going through the current transformer. We can implement on the generator side also 2 sets of voltage transformers. We are going even more down, having kind of a surge protection circuit, so surge arresters and surge capacitors can be installed, and then going through all the switching devices, meaning earthing switches on the generator side, generator circuit breaker, a main disconnector, and an earthing switch on the generator step-up transformer side. Then, of course, on the other side, there might be also the requirement to have a surge arrestor and surge capacitor being installed, going upwards again, having a current transformer and also another set of voltage transformers. If it's required, this can be installed. And what is now so unique, we have integrated local control cabinet inside the HB1 and still having an even smaller footprint than the existing or the HB1 which was existing in the past. So we are providing same functionality, standardized functionality, but with an even smaller footprint with it. And of course, I hope you have enjoyed our webinar beginning of this calendar year, where we have introduced you the new HB1C. With this new HB1C, we have also integrated in the new HB1. Why did we do this? Of course, we do have this modular approach, which is also recognized by the IEC IEEE standard as the best practice to install, not to only install, but to manufacture and to type test such kind of equipment. And it is getting even smaller. That's why we were able to guarantee an even smaller footprint with this new switchgear. This HB1C is available for a rated voltage up to 24 kV, also with the insulation level based on the IEC IEEE standard, and a rated current in free air of 6,700 amps. It is a perfect solution for retrofits, since it cannot be only in an I-shaped configuration, so all the alignment is in one axis, but also as an L-shape. So, as I said, perfect solution for retrofit applications, and if you have any questions, feel free to contact us for this. But for the HB1, since this was the best practice during R&D phase, we have decided to only use the I-shaped configuration of this HB1C, and we were really happy with that. Going deeper into this HB1C, of course, as I said, this HB1C combines all switching devices which are actually mandatory or required and mentioned by the standard. We do have the earthing switch on the generator side. We do have the generator circuit breaker, which is our well-known Siemens 3H37. We do have the main disconnector, an integrated main disconnector, and we do have an earthing switch on the step-up transformer side. All these components together have been type tested, which makes it really safe to operate, and also the combination has been type tested, which is pretty good and also well known and recognized by the IEC IEEE standard. As I said, of course, this modular design of the IEC IEEE was firstly announced with this new update of the IC IEEE back in 2022. And of course, it has an advantage in the reliability and the compactness of the whole generator circuit breaker system. Since it is one system, we do not have single components anymore, and all the components are integrated, connected, and type tested and routine tested together. Of course, since we are using for the HB1C and for the HB1 the 3H37 generator circuit breaker, we are using a spring drive mechanism which has been recognized by the Siegel Working Committee as the best operating mechanism. So we can provide, or the generator circuit breaker is able to have up to 10,000 closed open operations without any maintenance. And this is actually the most reliable way to operate a generator circuit breaker. So I don't want to go deeper into the functionality of the generator circuit breaker 3H37. If you do have any questions, please feel free to enter it in the question box. We are happy to answer it. Of course, this 3H37 is also fully type tested. It has been reconfirmed during the type testing campaign, which when we were having the HB1C development and also the new HB1 development. And yeah. So for the main disconnecting switch function, of course, this is also a component which has been pre-type tested, and we are using it to decrease the possibility to have a failure. So we are having more than one type test confirmed for this this connector, which is pretty safe. Of course, if you are needing it, you can have the earthing switch either on the generator side or on the transformer side, or even on both sides. This is up to you based on your requirements. These are all motor operators, as well as the disconnector and the generator circuit breaker. If you don't want to have a motor operation, it's also possible to have a manual hand crank operation for these switching devices. And as I said, with the new HB1, we are providing actually all the requirements of a generator circuit breaker system switchgear. We are having a current transformer. They are located on the generator side and on the transformer side. We can provide up to 4 secondary cores with the rate, and the maximum operating voltage on the primary side will be 17.5 kV. Of course, since it's a switchgear for 17.5 kV, this does make sense. The maximum primary current of these kind of current transformers will be 7,000 amps, with the maximum rated short-time thermal current up to 72 Ka for 3 seconds. Then we do have the potential transformers or voltage transformers to also use for the protection and measurement purposes. In total, we can provide on both sides, so on the generator side and also on the transformer side, in total 12 voltage transformers. They are fixed mounted on a mounting plate with the primary operating voltage up to 17.5 kV. Of course, if there are also some situations where you are facing surge voltages, that's why we also do have a surge protection included also on both sides, so generator side and transformer side. We do have the well-known zinc oxide surge arresters. They are fixed mounted. If you want to remove it, it's also possible, but it takes you some time because it's actually just a one-time installation. And of course, last but not least, even generator circuit or vacuum generator circuit breakers by Siemens do not require surge capacitors. It is possible to integrate them on the transformer side, and of course also again on the other side. Okay, coming back to the overall dimensions, which is also very crucial and a very good point to understand or to get an advantage out of it. We are talking now about a width of the whole HB1, including the low voltage control cabinet, of 4,100 millimeters. A total height, including the bus bars, including the customer interface, of 2,600 millimeters, and a total depth of 2,100 millimeters. With this size, we are even smaller than the former HB1. So we have increased the performance on the one side, but on the other side decreased the footprint of the whole switchgear. What is so unique, well, what is not unique, but what is also so special, since we are talking about standardized switchgear, it is possible for you to have not only the low voltage control cubicle on the right side, seen on this picture, but also on the left side on this picture. This is possible depending on your requirements, what you are going to need. Then, of course, as you have seen, we are always having a top-top connection via standardized flange. With this standardized flange, we want to make sure that you, as our customers, are having the flexibility to install each and every single possibility for several connection types. So, for example, you can have non-segregated phase bus, you can have the segregated phase buses, you can have medium voltage cable connections. This is also possible. You can solid insulated bus bars. You can also have IPBs. And of course, since the HB1 is flexible, you can also mix it up. So for example, on the generator side, you are having a solid insulated bus bars, and on the generator step-up transformer side, you are going with the non-segregated phase buses, providing, of course, the best flexibility to you. Then, of course, I told you that the main disconnectors and earthing switches, as per standard, are actually motor-driven switching devices. If you want to have a manual operation for the earthing switches, and also if you want to manually operate the disconnecting switch, you can see 3 boxes. The 2 on the bottom you are going to use for the manual operation for the earthing switches and for the main disconnector, just by putting a manual hand crank in it and having direct access to the drive mechanism. These boxes are locked, so you need a special key to open it, just to have a kind of a safety feature that not everybody is able, who is standing in front of the switchgear, to open the switching devices or to operate it. On the right side, you can see another box. Behind this box, you do have a GCB, a generator circuit breaker emergency switch off. So in case of any failure, or you need to open the generator circuit breaker, you are going to open this box via a special tool, and then you are able to switch the circuit breaker manually off. To wrap it up, what are the specificities and flexibilities of this HB1? Of course, we are talking about a maintenance-free, because we are integrating a vacuum, the vacuum interruption technology, which is maintenance-free, and we are also using a spring drive mechanism for the operating, for the motor drive of the generator circuit breaker. Then we do have the flexible and versatile solution. Of course, we are only providing the HB1 with top-top connections. But due to the standardized flange, we are able to provide each and every single connection box which you want to have. So, as I said, NSPB, SPB, SIB cable, or IPBs. Then, due to the fact that we have type tested it under the influence of an internal arc, we can also provide, and we have upgraded the personal safety of your employees. So it has been type tested not only based on the -200 standard, but based on the -200 standard with the limitations and the rating limitations of the IEC IEEE standard. So we have combined it, providing the best personal safety for you. And of course, another feature, the HB1C, so the heart of the HB1, can be removed by placing an optional external metal frame on that to allow an easy, faster maintenance of the HB1 and HB1C. Then we do have this modular assembly of this HB1C, and also for all the other equipments, medium voltage equipments you are going to have in the HB1. These are all manufacturing under workshop conditions, which is fast, clean, and reliable. We have this bolt-on approach. Of course, it is all completed and fully assembled in the factory and tested before delivery, of course. Then we do have the native interlocking, so the whole controlling of the generator circuit breaker and the other switching devices is having one native interlocking, which we are going to provide at the lateral sides of the switchgear. And one next or last important point is that we are having an F-gas-free system. So with this point of this F-gas-free system, we make sure that we are supporting the sustainability issues within your company. So we do not emit any greenhouse gases. We are having an air-insulated switchgear. We are using vacuum interruption technology. So that's it. Coming to the key takeaways from this webinar. What I want you to keep in mind is this HB1 is increasing your personal safety and also the reliability of your power plant by having a type-tested internal arc design. We do have this modular assembly, which has been recognized by the IEC IEEE Standard Committee as the best solution to manufacture, to install, and to develop such kind of a system. Also providing a maximum flexibility, and we have the opportunity to optionally remove the HB1C for a faster maintenance. We are going to reduce the project time and complexity by having only the minor modifications of the bus bar due to the very small footprint. We do not need any SF6 handling because we don't have any SF6. We also do not need to monitor any vacuum because they are sealed for life. We do have an integrated low voltage control cubicle, as I said, either on the right side or on the left side of the switchgear. And we also have a low maintenance requirement. So our generator circuit breaker and the operating mechanism is able to have 10,000 closed open operations without any maintenance. Furthermore, the generator circuit breaker and its contact system is able to have 10,000 interrupting cycles at a rated nominal current without any maintenance. And last but not least, when we are talking about full short circuit interruption, we can provide and we can make sure with the vacuum generator circuit breaker that we can have full 30 interruptions at full rated short circuit current without any maintenance, which is a very high number.